Okay, so we're on page 4, rational exponents. For any real number b with a fractional exponent, then b to the 1 over n is equal to the nth root of b, except when b is less than 0 or negative, and n is even. Okay, let's investigate that for just a second. If we have a fraction exponent, b to the 1 over n, what do you notice about the n? Where does it go when I write it in radical form? The denominator is the same as the index, right? So that's always the case. The denominator becomes the index. So I call this rational exponent form, and this guy right here is radical form. So we can transfer between the two because we know that the denominator is the same as the index. Okay, so number 1 there says write each expression in radical form. A to the 1 over 6. What's the denominator? 6. So what's the index going to be when I write it in radical form? 6, right? So this guy is the 6th root of A. So then letter B, when it says m to the 1/2, the denominator is 2, so the index will be 2. So that guy is the square root of m. Do I have to write the 2? No, you don't. Remember, if there's no number there, we assume m to be a 2. So we can just write it as the square root of m if you want. Okay, so if I give you in a rational exponent form, you can go to radical form, but the same way we can also go back the other way as well. So we can go from radical form to rational exponent form. So look here at number 2. I have the 5th root of b. Okay, awesome. Thanks, Gabe. So the index is 5, so that becomes the denominator. So I have b to the 1/5. And then letter B there. Remember, if there's no number there, we assume m to be a 2. So the index is 2. That becomes my denominator, so that's w to the 1/2. Now, it said that was the case all of the time, except for when b is negative and n is even. So I think, and n is even. So think about, we can't take the square root of -4, right? We can't take the square root of -16. Because we don't, there's not two numbers that are the same.
But you can take the cube.
But I could take the cube root of those guys. So all that's just saying is we still can't do it if we're taking an even root of a negative number.
Got it.
That's all that's saying. Okay? That's a lot of math words for just saying that. Okay, well, what happens if my fraction exponent, the numerator is not a 1? That's where this box comes in. So same thing. Unless b is negative and n is even, then it doesn't work. But in this case, we can keep the numerator under the radical, or we can take the root and raise it to the m power. Okay? So here's our big rule. There's two ways to do it. Okay? If we take raise it to the m power under the radical, it just makes our number bigger. If we take the root first and then raise it to the power, it's usually a smaller number. Okay, so grab your chart because we're going to need it. All right, so this one says evaluate each expression. I have 49 to the -1/2. All All right, let's talk about negative exponents for a second. What happens with a negative exponent? What's your rule from last chapter?
Makes the decimal go backwards.
Yes, if we're doing with scientific notation, what happens if we have it as an exponent, like on just a variable?
Makes it a fraction.
Makes it a fraction, right? It goes to the denominator. So this guy is going to become 1 over 49 to the positive 1/2. Okay, now let's turn this guy to radical form because I feel like that's probably more comfortable for you. So this guy, my denominator is 2, so my index is going to be 2. So this guy is 1 over the square root of 49. What's the square root of 49? We may not need our chart for this one. 7, right? So this guy is 1/7. It's a confusing way to write 1/7, right? That's a lot of numbers for 1/7. How about this one? 32 to the 2/5. Which one's the denominator? 5. Okay, so that's going to become my index. So let's rearrange this guy and write it as the 5th root of 32. And I'm going to then raise it to the 2nd power. So I'm going to take the 5th root first. So look at your chart. Lost mine. I'm going to go down the powers of 5. The 5th root of 32 is 2. Okay, so that guy then is 2 to the 2nd power. And what's 2 to the 2nd power? 4. Now, we could have done it the other way. Like I said, the rule said we could raise it to the power first. So we could have also done this guy as the 5th root of 32 squared. Well, 32 squared is a really big number, right? 32 squared is 1024. The 5th root of 1024 is 4. So you get there either way. If you take the root first, though, the numbers tend to be a little bit smaller. Okay, last one. 81 to the 3/4. What's the denominator? 4. So this is the 4th root of 81 raised to the 3rd power. Okay, so look at your chart. 4th root of 81. 3. Raise it to the 3rd power. 27. So when it says evaluate this expression and it's just full of numbers, you're just going to use your chart. Okay, when we simplify rational expressions, we're going to use our properties of powers from 5-1. That's all of those guys. Remember our exponent rules? We just talked about a negative exponent moves it to the denominator. If it's in the denominator, it moves it to the numerator. When I'm multiplying, I keep my base and add my exponents. When I'm dividing, I keep my base and subtract my exponents. Power to a power, we multiply. Remember those ones? All of those ones? So we're going to be still using all of those rules. We're just going to do it with fraction exponents. leave the exponents in rational form. All positive exponents. We can't ever leave an exponent that's negative, so we'll have to fix it if it's negative. Any exponent in the denominator must be a positive integer. Meaning, no fraction exponents in the denominator. You may have to rationalize the denominator. And if your answer, or if your problem starts out in rational exponent form, your answer should be in rational exponent form unless it's telling you to change forms. If it starts out with a radical, it should end with a radical unless it's telling you to change forms. Okay, now we have to have a little lesson on our calculator and fractions. Does everybody know how to use your calculator to do the fractions? Does anybody need to borrow a calculator? So, if you have an 84, you do have a fraction menu. Most of you. If you hit green and then y equals, it brings up your fraction menu. Have you all seen this? Okay, so let's practice adding some just random fractions. Add 1/2 and 2/3. Seven, 6. Does anybody need help with your calculator? Okay, let's multiply 1/2 and 2/3. You should get 1/3. Okay? So, normally, when we add fractions, what do you need? A calculator that does it for you. But what else? Common denominator, right? If you're not comfortable doing that, use your calculator. Does that make sense? I just showed you how to do it so that you don't get it wrong. Do you notice it's not 3/5? Okay, so you have to have a common denominator to add them. When you multiply them, you just multiply straight across. Okay? Like I said, I showed you your calculator. I don't want you to get hung up on what to do with the fractions. I want you to know how to do it when they're exponents. Does that make sense? So yes, if you're not sure, use your calculator. I'm okay with that. All right, so look at number 4. I'm multiplying y to the 1/7 times y to the 4/7. What does my exponent rule say when I'm multiplying? What am I supposed to do with my exponents? Add them, right? Okay, so I'm going to keep my base, and I'm going to add my exponents. Well, this one's nice and dandy because they both have a common denominator, right? If they didn't, I would just throw it in my calculator and make my calculator add it for me. So this guy is y to the 5/7. So in this section, you have to know what to do with your exponents, and then you also have to do with fractions. And that's it. That's all we can do. We don't have anything in the denominator. We're good. The exponents are all positive. We can leave them in fraction form. We're good to go. I'll put the exponent rule here. Okay, how about number 5 though? I have a negative exponent. Where's he going to go? to the denominator, right? Okay, so this guy becomes 1 over x to the 2/3. This guy right here, though, said any exponent in the denominator must be a positive integer. I can't have fraction exponents in my denominator. Well, right here I have a 2/3. So I have to fix it. So I have to do what's called rationalizing my denominator. So I want this guy to be a whole number. He's 2/3 right now. How many more thirds does he need so he's 3/3 or a whole? One more third, right? So, just like I did yesterday, I'm going to give my denominator 1 more third. And whatever I do to the denominator, I have to do to the numerator to preserve equality. If you multiply what's on top, the same thing on top of the bottom, remember that's 1, so I'm just multiplying by 1. So 1 times x to the 1/3 is just x to the 1/3 divided by, keep your base and add your exponents. 2/3 plus 1/3 is 3/3. So this guy becomes x to the 1/3. 3/3 is just 1. Okay, any questions so far? Okay. Let's go to number 6. This guy says the 6th root of 16 divided by the 3rd root of 2. First of all, do they have the same index? No. And if I did a factor tree for 16, would I get 6 of the same thing to come out? No, he's 2, 2, 2, and 2. So no. So I'm stuck. So let's change forms. He's in radical form. Let's go to rational exponent form. So the 6th root of 16 could be written as 16 to the 1/6. And the same thing with 2. I'll never get anything to come out, the cube root of 2. So I'm going to rewrite that guy as 2 to the 1/3. All right, well, my exponent rule says that in order to subtract those guys, they have to have the same base. Or 16 and 2, the same base. But could I make them the same base? You have to always go smaller. Which one's bigger, 16 or 2? Which one's bigger? 16. Can we rewrite the number 16 as a 2 with an exponent?
Yes.
2 to the 4th is 16. Okay, so we're going to rewrite this top guy as 2 to the 4th to the 1/6 divided by 2 to the 1/3. Okay, so power to a power. You multiply. 4 times 1/6. Oh geez. Should we use our calculator? What'd you say? 4/6, right? That's fine. Does that guy reduce? Okay, so that guy is 2 to the 2/3 divided by 2 to the 1/3. Do they have the same base now? Yeah, they're both a 2, right? And my exponent rule says keep the base and subtract the exponents. Okay, so this guy is 2 to the 2/3 minus 1/3. 2/3 minus 1/3. 1/3. We're almost done. He started out in radical form. He has to end in radical form. My denominator is 3, so my index has to be 3. So this guy ends up being the cube root of 2. Okay, questions on that one? That was a lot. That was a lot of steps. Okay, let's do 7 then. The 6th root of 4 times x to the 4th. Is 6 of anything going to come out of that guy? No. Okay, so let's change forms. This guy is now 4x to the 4th all to the 1/6. Okay, what's my rule say when I have a whole bunch of stuff inside the parentheses and they have an exponent out? Yeah, we got some power to a power and everybody gets it, right? So that 4 is going to get a power of 1/6 and the x to the 4th is going to get a power of 1/6, right? Alright, so this is 4 to the 1/6 x to the 4th to the 1/6. Can we rewrite 4 as something, a smaller number with an exponent? 2 to the 2nd, right? Okay, so let's do that. This guy is 2 to the 2nd to the 1/6, x to the 4th to the 1/6. And then JJ just said power to a power we multiply, right? Again, if you're not comfortable multiplying fractions, use your calculator. 2 times 1/6. 2/6, right? And does that reduce? 1/3. So this guy becomes 2 to the 1/3. Your calculator actually reduces for you. So if you're not sure, you could do it all at once. So you could do 2. Whoops, that's a 5. 2 times the 6, and it'll actually reduce it straight to 1/3 for you. Okay, how about x to the 4th to the 1/6? 4/6, does 4/6 reduce? 2/3, right? Okay, now, it started out in radical form, it's got to go back to radical form. Look at how fancy this is, our denominators are the same. So our index is going to be 3, right? So to go back to radical form, I'm going to now have the cube root of 2x squared. So yesterday I said your index has to be as small as you possibly can get it, meaning this is where that comes from. We have to reduce all these fractions as small as we can get them. So we started out with an index of 6, and then we ended up with an index of 3.
So we basically just divided the whole thing by 2.
We did, but we had to do a whole bunch of math before we get there. That won't always be the case. Okay, doing okay? All right, I ran out of room. So, grab a piece of paper for our number. 8. All right. Number 8 says y to the 1/2 plus 1 divided by y to the 1/2 minus 1. Okay, we got some junk going on. We've got a fraction exponent in the denominator. We also have 2 terms in the denominator. Well, yesterday when we had 2 terms in the denominator, we multiplied by the conjugate to get rid of it. Okay, so anytime you have 2 terms in the denominator and you have something that you shouldn't, you have to use a conjugate. Okay, let's change this guy to radical form. I think it'll be easier to see. Otherwise, we're dealing with lots of fractions, and I know you guys just love fractions, right? So let's change this guy to radical form, because I think you'll feel more comfortable with it, and then we'll put it back in rational exponent form when we're done. Okay? All right, so I'm going to rewrite this guy as the square root of y plus 1 divided by the square root of y minus 1. And now I have to rationalize by the conjugate. Remember, the conjugate is the exact same thing, but the sign in the middle is flipped. So the conjugate of the denominator is y, square root of y, plus 1. Okay, now let's FOIL the top and the bottom. And I'm just going to write it all out. So I have the square root of y times y is y squared plus 1 square root of y plus another 1 square root of y plus 1. And remember, when we multiply conjugates, those middle terms should drop out. So square root of y times the square root of y, again, is the square root of y squared. Outsides, plus 1 square root of y. Insides, minus 1 square root of y, minus 1. So my plus 1 root y and my minus 1 root y are going to cancel. And then let's simplify this guy. What's the square root of y squared? Y. So that guy turns into y. And yesterday we learned how to add radicals. The index has to be the same and the radicands have to be the same, and then I can just add the numbers out front. So what's 1 plus 1? 2. Square root of y plus 1 divided by, we decided the square root of y squared was just y. That guy is a minus 1. The middle terms dropped out. We're so close. Sorry, that's a really bad looking square root of y. We have to go back to fraction form. Okay? If you notice, we got rid of all the radicals in the denominator. That's what we wanted. We don't want any radicals in the denominator. That's why we have to rationalize. So this guy right here, weird, is the only guy that needs to be changed forms. So there's a 2 out front. So this guy becomes y plus 2y to the 1/2 plus 1 all over y minus 1. And I wrote really big. Okay, questions? How do you know when you're done? Well, the next page answers that question. So, an expression is completely simplified when it has no negative exponents. It has no fraction exponents in the denominator. Or radicals in the denominator, if you will. And the index on the radical is as small as possible. Meaning that you simplified your fractions or reduced all of your fractions.
What is the other one called? The other, like, not the denominator. Oh,
Numerator.
I was thinking predicate or something.
Getting a little switch of English going on in there. Okay, so look at number 9, last one. I have 2x to the 1/8 divided by x to the negative 1/16 x to the 1/4. Well, that's nasty, right? Maybe. Well, what do you want to do? What do you think? Just throw it in the trash and start over, right? Yeah, I'm not going to do that one. Ask questions on it on your homework, right? Hey, could you do number 9 for me, Mrs. Snowden? Right?
Probably.
Yeah, probably. Okay, so let's look at the denominator. Do we have the same base? Are there some x's down there? Okay, let's just look at the denominator. Essentially, what are we going to have to do to those 2 exponents? What'd you say, Amelia? Add them. Let's see if we can add them together first. What do you think about that idea? But yeah, if we still have an exponent, we're going to have to fix it, right? Okay, so let's just use our calculator, right? Because we know we're going to have to add those 2 guys together. We could get a common denominator, but let's save ourselves some trouble. I got negative 1/16 plus 1/4. Okay, look, that's handy, right? 3/16. Okay, let's do that. That's a little bit better, right? Well, if we are going to think about common denominators, essentially, what would I do with those 2 exponents? When I divide, I subtract, right? So I would eventually have to subtract those guys. Well, 1/8 is really 2/16, yeah? So where's the bigger one, on the bottom or on the top? On the bottom. So even if we do subtract them, we're going to end up with a fraction exponent in the bottom. So let's instead see if we can rationalize this guy. All right, so I just said 2x to the 1/8 is 2/16. So if we were to subtract them, we'd end up with 1 more 16th on the bottom. But let's just go to rationalizing, because we know we're going to end up with a fraction exponent. So let's just get him to be a whole number anyway. So I've got 3/16. How many more 16ths do I need to give him so he's a whole number? 13, right? All right, so I'm just going to rationalize by 13/16. Okay, now, remember you do it to the bottom, you got to do it to the top. So that I'm essentially multiplying by 1. So 3/16 plus 13/16 is 16/16 or 1. Okay, so my denominator has just turned into x to the first. And then I have my 2 out front, and I have 2/16 plus 13/16. 15/16. We got rid of all negative exponents. We don't have a fraction exponent in the denominator, and we don't have to worry about our index. Well, our fractions are all reduced, so our index is as small as we possibly can get it. Does that help? Questions on that one? Or anything that we've talked about? That's okay. Okay. I'm going to push pause.